Hello, my name is Mohit Doshi. This is the presentation for my CSE 335 class project, UniNavigate. The inspiration for this project came from three avenues. Campus can often be difficult to navigate, especially for new students. As students are increasingly leaving the pen paper medium of taking notes and shifting to electronic devices, they need a system that doesn't mix up notes for different courses and one application to access everything. Data privacy is very much a threat online, and even users with private accounts on social media have reported their personal information being stolen or used without authorization. The solution was to build an iOS application that acts as a campus diary. The app displays various buildings, floors, and the classrooms on ASU's Tempe campus. The user adds a course to a classroom and then customizes the details for the course by adding notes and images. All user information and data is stored on the device only and cannot be accessed by anybody else. The user can go back and edit any of the notes and images associated with the course whenever he or she pleases to. The app will also display the location of the building and the user on a map to aid navigation. This is the class diagram for my project. Starting with the non-view controller classes, the course info class represents a core data entity which has variables that store user data such as notes and images. The course info module class usually adds to or retrieves from and also updates the objects in core data. The view controller class represents the home page for the app. It has objects for the course info module class to display a list of courses being tracked and the buildings API call class to get the JSON object from the web API call. The buildings API call class entirely handles this and serves to only return data received from the API call. The classes which have table views include the list of buildings view controller, list of floors view controller, and the list of classes view controller. Each of these classes is associated with a class for their table view cells so that the cells can be configured in a custom manner. All of the view controllers are linked, and the table views depend on information received from the previous view controller to be able to display information. The view controller sends JSON data to the buildings view controller class via a segue method, and the buildings view controller class then parses some of this data to list the buildings. Clicking on a building shifts the view to the floors view controller and sends an array via segue, which the table view uses to list the floors in the building. Similarly, clicking on a floor sends a dictionary object via the segue method and loads a list of classrooms. Finally, clicking on a classroom loads the information in the detailed view controller class. The detailed view controller and list of classes view controller class have objects created for the course info module class. The detailed view controller uses the object to check for a previously existing course, load, add, or update course information. The detailed view controller unwinds the segue if the user presses the save button or does not enter a course name when prompted. The floors view controller class also has methods which deal with adding content to the map view. The various delegate methods in the class deal with location and map annotation related functions. The class diagram primarily describes associated relationships, but the highlight is the composite relationship between view controllers. One of the requirements for the project was that it had to be designed considering MVC or Model View Controller Architecture principles. The controller represents the view controller classes in my program. Its functions include retrieving the JSON data from the model returned via the web API call, retrieving a list of courses being tracked from the course info module class, and parsing the JSON object at various stages to obtain specific data. The controller calls all the delegate methods for the table view, image picker controller, location manager, and map view features. It also updates the table views, image views, text views, and other UI features. At the logical level, it is creating the course info object to add or update information for a course. It is also receiving and updating the list of tracked courses from the model. The model for my project is split only between three classes. The Buildings API call class is the part of the model that calls the remote web service and returns the JSON data. The other classes in the model deal directly with core data, sorting, retrieving, updating, analyzing the information stored in the entities. Also returns a list of courses that are being tracked. The model notifies the controller if there are any changes in the JSON data with respect to the buildings, floors, or classrooms, and also if a new course has been added. The view for my project communicates with the controller to display data either in the model or loaded from elsewhere in the program. It notifies the controller whenever a button or a cell in the table view is clicked or if the map is clicked. It also notifies the controller when an image is captured or selected. It displays the buildings, floors, classrooms, and table views, the locations on the map view, and user information such as notes, images, and the name of the course. This is the home page for UniNavigate. It displays a start button and a text view containing the list of courses currently being tracked. Clicking on start will load a list of buildings. It gets this by parsing the JSON object returned from the API call. And suppose I click on Core Hall, it'll load all the floors that are there, the hall, and a map view displaying the location of Core Hall. I could even load my current location and just get a sense of where I am with respect to Core Hall. And then clicking on a floor will load the list of rooms available. And suppose I click on room 174. See that I've already added a course over here, 35. Can navigate between notes, delete them, can change images. Can hit save and saves this to core data. That way when I go back to the classroom, you can see that there are no notes. The image has been changed. I can even add my own course. Suppose I have CIS 105 here. Could add something like low add an image, add another image, then saves this to core data. I could go back, access the floor, display the notes, the images. When I go back to my home page, it shows the newly added course. To summarize, the app displays all buildings, floors, and classrooms on campus. It has location-based map features that show a building and a user's location. It allows users to add a course and edit information for that course, which is then stored in core data. It also lists the names of the courses that are being tracked for the user. With regard to limitations, the application does not account for the case where two or more courses can be held in the same classroom. User information cannot be migrated to another device since it is stored in core data. The application also lacks the ability to automatically pre-populate the courses for a user by accessing a schedule or calendar. Lastly, the application only runs on iOS-supported devices, and not all students own such products. This project was the first time I carried an individual project for a course. I have learned a lot about planning ahead, storyboarding, and meriting an idea that can be applied to build a project out of. At a technical level, perhaps my hardest challenge for this project has been setting up and deploying my own API. I had never done this before and had to learn how to do it online. I used Amazon's AWS Lambda to deploy the API due to its ability to run code serverless. I've also gathered a lot of resources with respect to documentation and Swift forums during the course of this project. I've become very familiar with core data storage for images, which wasn't my strongest suit despite the labs. I've also gone on to apply MVC principles for group projects and other courses and hackathons, and doing so has made me more comfortable with the concept, so I was able to easily design my project as per the MVC architecture. Delegate methods are another topic that I've gained a sound understanding of through this project. I've come to understand why they are implemented, and I was able to work with them really well in my project. I built this app in such a way that I've predicted what the user will be doing before they actually perform an action, in most places. I call the API as soon as the app loads rather than wait for the user to press start. I have the user's location coordinates already loaded even before they press the button to view their location. Also borrowed some robust error checking considerations that make my application foolproof to an extent. With regard to suggestions for improvements for the class and project, Having not taken 310, the workload for this class has been exponentially higher than the other courses I've taken. I felt I'd have been more prepared for this course, at least in the beginning, had I taken CSE 310 earlier. Core data, although generously touched upon in class, felt underrepresented in the labs and homework assignments. I feel more time on working with core data could have made some parts of my project easier to design. I'd like to suggest giving the project topic to the students rather than have them come up with their own idea. It would also be nice if one class in the semester could be reserved for industry representatives to come talk about internships, jobs, etc. for iOS app development. Also, the course could highlight programs like the WWDC scholarship and recommendations on what is expected. Thank you for listening. My name is Mohit Doshi, and this is my Phase 3 submission for the Principles of Mobile Application Development course at Arizona State University.